Welcome back, guys. This is 3.7 part 2. We were talking now about how to graph rational functions. Last time we talked about finding asymptotes and the zeros. Now, when we're graphing, the first thing we want to make sure that we do is check that our function is in lowest terms. That means everything's factored, and if there's anything I can cancel it. Here we see it's already factored, and there's nothing that I can cancel, so I can skip ahead to the next step. Next step is to find the zeros. Zeros are just from the factors on the top, things that are going to make it 0. So in this case, there's only one 0. That's x equal to -1, because that will be -1 plus 1 on the top, which makes it 0. And then next, after that, we look for the asymptotes. So we'll abbreviate vertical asymptote first, VA. That's the line that's going to be make it 0 on the denominator. So it's going to be x equal to +1. That will make it 0 on the denominator. Then we look for any oblique or horizontal asymptotes. In this case, we have the power same in the top and bottom. So the horizontal asymptote is going to come from the division of the top coefficient by the bottom coefficient. And that's equal to 1 divided by 1, or just 1. Remember, horizontal asymptotes, they have the form y equals to the number, because that's the equation for a line that's a horizontal line. Alright, so now let's go to graph the thing. When you go to graph the thing, I'm going to start by plotting the zeros and the vertical asymptotes. Actually, I'm going to just write all three asymptotes. So first of all, x is equal to -1, that's a 0. So I'm going to plot that point right there at 0. And then what else do I know? It has a vertical asymptote as x equal to 1. So that's right here. Let me do my asymptotes in red. So this asymptotes we do in dotted lines. And then horizontal asymptote at y equal to +1. So here's 1 here. That means I have a horizontal asymptote right there. Sorry, my lines are crooked. It's a little just awkward to write from the ground like this where I am. Okay, so the next thing I want to do is just find points in each interval. So to the left of this 0, in between this 0 and this asymptote, and then to the right of this asymptote. Okay, so what's to the left of -1? How about -2? Yeah. And what's in between? How about 0? Yeah, 0 over there. And then this is 1, what's to the right of 1? How about +2? Okay, so let's see what happens. If I plug in -2, that's -2 plus 1, that's -1, over -2 minus 1, that's -3. So -1 over -3, that makes +1/3. So it's positive, and it's right about there, a third. And then, let me just plot that point there. At 0, it's going to be 0 plus 1 over 0 minus 1. That's 1 over -1, which is -1. So at 0, it's going to be right here in -1. So I'll plot that point right there. And I'm just going to connect the dots. As I connect the dots, I'm going to keep in mind my graph should approach this horizontal asymptote as it goes out to the left. It's going to cross through those 2 points and then approach this vertical asymptote without ever crossing as it approaches the bottom. Generally speaking, lines will not typically cross the horizontal asymptote as they go out, but sometimes they can cross horizontal asymptotes in between somewhere. Vertical asymptotes, they will never cross. Okay, now for +2. So if I plug in +2, that's 2 plus 1 is 2. 2 minus 1 is 1. So that gives me +2. So +2 is up here. That means I'm at the top of the graph. It should approach the vertical asymptote like that, and then approach the horizontal asymptote like that. And there's the graph. There's the graph for x plus 1 over x minus 1. Okay, I'm going to move on to problem number 2 now. Okay, let me find the problem. Alright, problem number 2. It says graph f of x equal to x over x squared minus 4. Alright, so the first step is to simplify. In this case, simplification just means I'm going to factor. It's always the first step. X over x squared minus 4 is actually the difference of squares, x plus 2 and x minus 2. And here there's nothing that I can cancel, so this is as simplified as I can get. That's the first step. Second step is to find the zeros now. So zeros, it's right over here. Actually, there's only one. that's when x is equal to 0, right? That's going to make it 0 on the top and 0 overall. Then now we have the vertical asymptotes. That's when this denominator is 0 in the simplified form. So that's x is equal to -2 and x is equal to +2, those two vertical lines. Now for the horizontal asymptote. Horizontal asymptote. Now this time you notice at the top has a power that's lower than the denominator, which means my horizontal asymptote is just going to be y is equal to 0. This is coming back from last class's asymptote discussion. Okay, so let's go to graph the thing. First, I'm going to start by graphing the 0. There's only one, x equal to 0. That's this point right there. Boom. Okay, next is the vertical asymptotes at x equal to -2 and +2. -2 is right here, vertical asymptote. Like that. And then positive asymptote, x equal to +2, that's the other vertical asymptote. Alright, horizontal asymptote is at y is equal to 0, so I'm going to just dot this line here right along the axis. Yeah. Just keep in mind this is the asymptote. Should approach that as I go further out to the left or to the right. Okay, now let's just check each individual interval. So I have a bunch of intervals to check this time. To the left, this is -2, so I should check -3. Right here, -1 in between the 0 and this asymptote. Here, +1 between the 0 and that asymptote, and then here's something at +3. So I should check 4 points. Alright, if I stick in -3, that's -3 in the top. -3 squared is 9. 9 minus 4 is 5. So I have -3 over 5, which is a negative value, -3/5. So -3/5 somewhere over here. Just guessing here. That means, okay, as far as the graph is concerned in this portion, it's going to approach this horizontal asymptote. So it's never going to cross 0, but it's going to get close to 0. It's going to approach this vertical asymptote like that. Oh, I just remembered. I'm doing my graphs in blue, so let me redo that. Asymptotes are going to be in red, and graphs will be in blue. You know what? Let's graph the point in black, though. Black point right there at -3/5. And then the graph approaches that line, passes through the point, and then approaches that line. Okay. This should be a smooth curve. Imagine this is a smooth curve. Okay, next portion, -1, in between -2 and 0. -1 is -1 on top. -1 squared is 1, minus 4 is -1/3. Yeah? So -1 over -1/3 is +1/3. Okay, so right over here I should be at +1/3. There's something like over here. Okay, what about at the 0? Okay, it's going to pass through the 0, alright. And then what about over here at +1? It's going to be 1 over 1 minus 3, minus 4 is -3. So +1 over -3, that's -1/3. That gives me this point right here. Alright, so then my graph should approach this asymptote, right? And then it's going to have to cross through that 0, and then it's going to, oh, I missed that point. It's going to pass through the 0, and then it's going to cross through this point I just plotted, and then it should go down like that. That's kind of an ugly graph, but it should be a smooth curve like this, just kind of passing through. Like that, something like that. Okay, so see how it approaches the two asymptotes, passes through the 0, and passes through my 2 points. The point of choosing these points is really to determine if I'm going to be above or below the x-axis. I'm going to be positive or negative. And so I got this piece, I got this kind of squiggly piece, and on the right side, I got to check if it's going to be above or below. And so if I plug in 3, that's 3 in the top. 3 squared is 9, minus 4 is 9 minus 4 is 5, so it's +3/5 this time. Last time was -3/5. This time +3/5 over here. So I should again approach the vertical asymptote and then approach that horizontal asymptote. Okay, so that's the sketch of my graph right there. That's number 2. Okay, let's cut it off because this video is about 10 minutes long. So we'll cut it off here and go to the next problem in the next video.